A massive object, shrouded in the cold darkness of space, hurtles toward Neptune, the most distant planet in our solar system. In a fleeting moment, it slams into the ice giant's turbulent atmosphere, unleashing a spectacle of heat, shockwaves, and luminous streaks that ripple across the planet's blue expanse. This isn't science fiction. It's a real event captured in stunning detail by the James Webb Space Telescope in the summer of 2025. The collision, a rare and violent cosmic drama, has shaken planetary science, offering a front-row seat to the dynamic forces still shaping our solar system. Today, we're diving deep into this extraordinary discovery, exploring what it tells us about Neptune, the outer solar system, and our place in the universe. If you're as excited as we are about this cosmic spectacle, smash that like button and subscribe for more updates from the edge of the cosmos. Neptune, often called the blue jewel of the solar system, has long been a source of fascination and mystery. Located over 4 billion kilometers from Earth, it's a world of icy winds faster than the speed of sound, colossal storms, and an enigmatic atmosphere of methane, hydrogen, and helium. For centuries, it remained hidden, discovered not through telescopes but through mathematical predictions in 1846, when astronomers noticed Uranus's orbit wobbling under Neptune's gravitational pull. Since then, Neptune has been a distant enigma, visited only once by Voyager 2 in 1989. That flyby revealed a world of dark storms, faint rings, and an active moon system, but it left us with more questions than answers. Now, thanks to the James Webb Space Telescope's infrared eyes, Neptune is back in the spotlight, transformed from a quiet sentinel into a stage for cosmic violence. The massive object that struck it wasn't just a fleeting event, it's a window into the relentless forces sculpting our solar system. What makes this collision so remarkable is its sheer scale. The object, likely a dark, icy fragment from the Kuiper Belt or a rogue asteroid, was massive enough to penetrate deep into Neptune's atmosphere. Unlike a comet that might burn up in a fiery streak, this body plunged through layers of gas, releasing energy equivalent to billions of tons of TNT. The impact sent shockwaves rippling across the planet, creating bursts of heat and luminous streaks that briefly lit up Neptune's shadowed regions. Webb's instruments, designed to peer into the early universe, captured these infrared signatures with unprecedented clarity, revealing how the planet's atmosphere absorbed and redistributed this sudden injection of energy. For scientists, it's like watching a natural experiment unfold, offering direct evidence of how Neptune's dynamic atmosphere responds to cosmic assaults. This isn't just a spectacle. It's a chance to test decades of computer models against real-world data. Let's talk about the object itself. While Webb couldn't directly sample its composition, its infrared data suggest it was a dense, rocky core surrounded by icy materials, possibly a Kuiper Belt fragment dislodged from its orbit. The Kuiper Belt, a region beyond Neptune filled with icy remnants from the solar system's formation, is a cosmic graveyard of primordial debris. Some of these objects, nudged by gravitational tugs, embark on long, elliptical journeys that can cross planetary paths. Neptune, sitting at the edge of this chaotic zone, is both a shepherd and a target, guiding smaller bodies while occasionally taking a direct hit. This collision confirms that Neptune's location makes it uniquely vulnerable to such impacts, challenging the idea that large-scale collisions are relics of the solar system's early chaotic years. Instead, they're an ongoing part of its evolution, happening even now, 4.6 billion years after the planets formed. The implications for planetary science are profound. Neptune's atmosphere, a swirling mix of gases, is a complex system driven by extreme weather. Its jet streams, reaching speeds of 2,400 kilometers per hour, and massive storms rivaling Jupiter's Great Red Spot, make it a natural laboratory for studying atmospheric dynamics. When the impact occurred, Webb recorded how the energy spread, creating shockwaves that interacted with existing weather patterns. These disturbances offer a rare glimpse into how Neptune's atmosphere processes sudden disruptions, from the upper clouds to deeper layers. This data is invaluable, not just for understanding Neptune, but for modeling exoplanet atmospheres, many of which are gas or ice giants like Neptune. By studying how this impact altered Neptune's chemistry and weather, scientists can better interpret the light signatures from distant worlds, distinguishing between natural storms and impact-driven chaos. This event also raises questions about planetary defense closer to home. Earth, though partially shielded by Jupiter's massive gravity, isn't immune to wandering objects. The collision on Neptune serves as a stark reminder of what could happen if a similar object crossed our path. In 1994, Jupiter's Shoemaker-Levy 9 impact showed us the scars of a comet's collision, visible even through amateur telescopes. Neptune's event, captured in exquisite detail by Webb, takes this understanding further, offering a framework for modeling impacts on Earth, Mars, or even habitable exoplanets. It's a cosmic wake-up call, underscoring the importance of asteroid tracking and deflection strategies. Neptune, in enduring this blow, has become an unwitting test subject, helping humanity prepare for potential threats in our own backyard. Beyond the science, there's a human angle to this discovery. The James Webb Space Telescope, a marvel of engineering, wasn't built specifically for planetary impacts. Its mission is to study the early universe, distant galaxies, and star formation. Yet, its adaptability, those finely tuned mirrors and infrared sensors, allowed it to capture this fleeting moment with breathtaking precision. This achievement is a testament to the scientists, engineers, and visionaries who spent decades bringing Webb to life. From its launch in 2021 to its first images in 2022, Webb has consistently exceeded expectations, proving that humanity's curiosity can yield unexpected dividends. This collision, recorded by an instrument orbiting 1 million miles from Earth, reminds us of the power of collective ingenuity to uncover the universe's secrets. Neptune itself is a world of contradictions. It's a frozen giant, yet its atmosphere is one of the most dynamic in the solar system. Its magnetic field, tilted and offset, puzzles scientists, and this impact might offer clues about its origins. The shockwaves from the collision could have stirred the planet's conductive layers, potentially altering its magnetic field or intensifying auroral displays at its poles. While Webb can't directly observe these auroras, future observations with other telescopes might reveal whether Neptune's skies now shimmer with new energy. The impact could also have affected the planet's moons, particularly Triton, a captured Kuiper Belt object with its own active geology. Gravitational ripples from the collision might have stirred dust in Neptune's faint rings or shifted moon orbits, hinting at the interconnectedness of planetary systems. Let's address a common misconception: that the outer planets are static, unchanging worlds. Neptune's collision shatters this notion, revealing a solar system in constant motion. Impacts like this aren't just destructive, they're transformative. Earth's moon likely formed from a massive collision billions of years ago, and similar events may have delivered water and organic molecules to our young planet. Neptune's impact suggests that such processes continue, subtly reshaping planets over time. The chemical signatures from the impactor, now mixed into Neptune's atmosphere, could alter its color, density, or cloud structure, offering a real-time case study in planetary evolution. Scientists will track these changes for months, perhaps years, as Neptune's atmosphere absorbs and redistributes this alien material. This discovery also rekindles interest in future missions. Neptune has been overlooked since Voyager 2's flyby, with Mars and Jupiter's moons dominating exploration plans. But Webb's images have thrust Neptune back into the spotlight, sparking calls for a dedicated orbiter or probe. Such a mission could monitor the planet's weather, rings, and moons, building on Webb's data to unravel the mysteries of ice giants. Imagine a spacecraft orbiting Neptune, watching its storms evolve or detecting the faint tremors of future impacts. This collision has made one thing clear: Neptune is not a forgotten outpost, but an active laboratory, demanding our attention. The philosophical resonance of this event is hard to ignore. For centuries, humans have looked to the stars for meaning, seeing planets as eternal fixtures in the sky. But Neptune's collision reminds us that the cosmos is anything but static. It's a place of chaos, beauty, and relentless change, where even the most distant worlds can flare with sudden violence. This event, unfolding 4 billion kilometers away, feels startlingly alive, a reminder that the universe is not a backdrop but a stage of endless drama. Webb has given us a front row seat, capturing not just data but a story written in heat, light, and motion, a story of resilience, transformation, and the ceaseless dance of cosmic forces. As we wrap up, let's reflect on what this discovery means. The collision on Neptune, captured by the James Webb Space Telescope, is more than a fleeting spectacle. It's a window into the dynamic nature of our solar system, a chance to study planetary atmospheres, magnetic fields, and cosmic impacts in real time. It's a reminder of our vulnerability and our potential as humanity's tools reveal truths about worlds we may never visit. From the Kuiper Belt's ancient relics to Neptune's turbulent storms, this event connects the dots between our planet and the farthest reaches of the cosmos. It challenges us to keep exploring, to keep asking questions, and to keep marveling at the universe's surprises. If this video sparked your curiosity, give it a like, subscribe, and share your thoughts in the comments below. What does Neptune's collision mean to you? Thanks for joining us on this cosmic journey, and we'll see you next time for more stories from the stars.